let's remind ourselves of how to do long division. When it comes to numbers, when we have 38 divided by 2, what we're really saying is 2 goes into 38. And we just take it one digit at a time and we ask ourselves, this 2, how many times does it go into 3? What am I going to have to multiply that 2 by to get it into 3? And we can multiply it by 1. 1 times 2 is 2. So we subtract, we get 1, and then bring down the 8. How many times does 2 go into 18? Well, that's 9 times. 9 times 2 is 18. We subtract, and we get 0. So 38 divided by 2 is 19. This number right here. And sometimes it doesn't work out so nice. So if we have 38 divided by 11, we're asking ourselves, how many times does 11 go into 38? Well, that'd be 3 times, and 3 times 11 is 33. So we subtract it and get 5. When we have that remainder, we could rewrite our answer as 3 with a remainder of 5, so that's 5/11ths left over. Now, how do we do it with polynomials? Well, it's the same way. And what we're going to want to do first is rewrite it as x minus 2. How many times does that go into x cubed plus 5x squared minus 7x plus 2? And it's not too bad. What we have to do is just look at this first term, this x term, and ask ourselves, how many times does it go into x cubed? Well, what do we have to multiply x by to turn it into x cubed? And that will be x squared times. So x squared times x is x cubed, and x squared times negative 2 is negative 2x squared. So we go ahead and subtract this thing. X cubed minus x cubed, that's gone, but 5x squared minus negative x squared is 7x squared. Bring down the next term. And do it again. What am I going to have to multiply x by to turn it into 7x squared? Well, we'll multiply by 7x. 7x times x is 7x squared. 7x times negative 2 is negative 14x. So subtract it. And make sure you subtract the whole thing. 7x squared minus 7x squared, that's 0. But negative 7x minus negative 14x turns into positive 7x. Bring down the plus 2. X needs to be multiplied by 7. 7 times x is 7x. 7 times negative 2 is negative 14. So subtract the whole thing. 7x minus 7x, that cancels, but 2 minus negative 14 is 16. There we have a remainder. So our solution is going to be right here, that polynomial with this remainder. So we could rewrite this, our solution, as x squared plus 7x plus 7 plus our remainder over x minus 2. Now we can do that synthetically as well. Let's do the same problem, this time using synthetic division. Synthetic division is exactly like that synthetic substitution that we just learned, but we take all of the coefficients of this polynomial, 1, 5, negative 7, and 2. And we just set it up, our horizontal lines and our backwards L, and what we're going to divide by is not x minus 2. Well, we are going to divide by x minus 2, but the number that I put up here isn't x minus 2. What I'm going to plug in there is 2, because 2 is what's going to make this thing equal to 0. Right? If x minus 2 is a factor, we want to look at the root of that 2. So, bring down the 1. Multiply and add. So we always multiply by this thing. 1 times 2 is 2. Add them together makes 7. Multiply by that 2 is 14. Add those two together, we get 7. Multiply by 2, we get 14. Add these two together, we get 6. Then we can see that our solution is going to be right here with our remainder. X squared plus 7x plus 7. And our remainder is 16, so we put it over x minus 2. And there's our solution. Notice, if I let f of x be that same polynomial, x cubed plus 5x squared minus 7x plus 2, then what we just showed is that we could rewrite this division as x squared plus 7x plus 7 and our remainder over 2, or over x minus 2 as a fraction. So what I'm going to do now is just a little bit of math magic here. What I'm going to do is just multiply by the denominator of this fraction, and it'll get those two to cancel. Whatever I do to the left side, I also got to do to the right side. So on the left-hand side, I'm just left with f of x. So I'm rewriting f of x. And I'm going to distribute this in to both pieces. This x minus 2 is going to get multiplied by the quadratic, x squared plus 7x plus 7. And it's also going to get multiplied by this fraction here. But when I multiply by this fraction, those two cancel and I'm just left with 16. It's just rewriting it in another form, but the nice thing about this is, now, let's find out what f of 2 is. Well, when I plug 2 in, this factor, 2 minus 2, turns into 0. This factor, 2 squared, that's 4 plus 14 plus 7, that's 25. Plus 16, our remainder. But it doesn't matter what that 25 was because I'm multiplied by 0. So that thing's going to be 0. And we see that f of 2 is equal to 16. So let's go back one frame here. And we just saw that f of 2 is equal to 16. That's kind of interesting because 2 was the number that we divided by, and 16 was the remainder. And that is always going to happen, which is why we have the remainder theorem. The remainder theorem tells us if a polynomial f of x is divided by x minus k, then the remainder, r, is also equal to the functional value f of k. So let's try a new function, 3x cubed minus 4x squared minus 28x minus 16. First, let's just divide it by 1. So, bring down the 3, multiply by 1, and add. Multiply by 1, and add. Multiply by 1, and add. And what we have here is our remainder. Therefore, f of 1 is equal to negative 45. So that's that synthetic substitution that we were doing before. When we run through synthetic division, the remainder is the functional value. Let's try negative 1. So let me clean this up a little bit. And bring down the 3. Multiply and add. Multiply and add. Multiply and add. Therefore, f of negative 1 is equal to the remainder, 5. Try one more. Add 2, negative 2. Bring down the 3. Make some room. So multiply and add. Multiply and add. Multiply and add. Therefore, f of negative 2 is equal to 0. Let's take a closer look at this last result. Here's that function, f of x equals 3x cubed minus 4x squared minus 28x minus 16 again. And this was our last line of work. And see, the thing is that through this synthetic division, we can rewrite f of x as x plus 2, because that negative 2 is going to make x plus 2 equal to 0, times this polynomial, 3x squared minus 10x minus 8, and we'll have a remainder of 0. That's what the remainder part tells us right here. Well, the nice thing is, if we have a remainder of 0, that means that x plus 2 had to be a factor. I mean, think about it. When it was numbers and we had 38 divided by 2, that was equal to 19. It didn't have a remainder, so both 2 and 19 are factors of 38. We can multiply them together to get 38. And so this brings us to the factor theorem, which says if f of x divided by x minus k has a remainder of 0, then x minus k has to be a factor, which we just kind of showed right there. But it allows us to continue and go a little bit further. Since we already know what one of those factors of f of x is, that's x plus 2. And then we still have this 3x squared minus 10x minus 8. Well, we can use what we know about quadratics to factor that part into 3x and x. And we can factor 8 into 4 and 2 to make 12. Negative 12 plus 2 will give us that negative 10x that we need right there. Still have x plus 2. And so we factored f of x into x plus 2 times 3x plus 2 times x minus 4. Now we can see all the factors of f of x. So the factor theorem helps us to factor more complicated polynomials once we find one of them.